Homework number 13. The first section asks you to state if each equation shown is linear or nonlinear. In order to do that, you have to review the 4 rules. An equation is linear if it can be written in the form y equals mx plus b. And sometimes you can tell that it cannot be rearranged into this form because it breaks one of these 4 rules. The first rule is that there can be no powers or exponents. So this is linear. But as soon as I introduce an exponent to the variable, it's nonlinear. This is linear. Now it's nonlinear. This is linear. Now it's still linear. So don't get tricked. Not every exponent is bad. Only exponents on the variables are bad. The second rule is no variables in the denominator. This is linear. This is not. No products of variables. This is linear. This is linear. But this is not. That is a product of variables. And the last one is no roots or absolute value bars on any of the variables. This is linear. This is not. This is linear. This is not. All right, let's take a look at our questions. Number 1, is this linear or is it nonlinear? So we look at the equation and see if it breaks any of the rules. Do the letters have any exponents? No. Are there any variables in the denominator? No. Are there any products of variables? No. Are there any special roots or absolute value bars? Nope. It doesn't break any of the rules. So this is linear. Next question over here, look carefully at your x and y's. Check to see if they break any of the rules. No exponents, no variables in the denominator, no variables timesing each other, that's called a product, and no special characters like roots or absolute value bars. So this is linear. In the next question, when I look at my variables, I notice this x has an exponent. That means it broke a rule, so it is nonlinear. For question number 2, when I look at my variables, I notice the x is in the denominator. That means this is nonlinear. It broke a rule. Question number 3 doesn't have any exponents, doesn't have any variables in the denominator, doesn't have any products of variables, and doesn't have any special roots or absolute value signs. That means this is linear. It looks like the next question breaks a rule. That means it's nonlinear. So question number 4 asks you to explain in words how you were able to determine your answer for why this equation is nonlinear. And the answer is, it is nonlinear because it cannot be written in y equals mx plus b form. And the reason for that is, if you want to add some more detail, because it has a variable in the denominator. This green sentence is optional. You can just say the red sentence. All right, let's take a look at the next section. Find the rate of change of the following data. A rate of change can be found using this slope formula. So my y2 is 8 and my y1 is 5. My x2 is -7 and my x1 is also -7. Remember, you have 2 negatives in a row here. So let's compute. 8 minus 5 is 3, but -7 plus 7 is 0. Anytime you have a 0 in the denominator, that means your answer is undefined. Question number 6. Identify the rate of change in the following equation. The rate of change is the coefficient of x, which for us is -4, but don't write the x. Number 7. Which of the following graphs represents the equation y equals 4 minus 2x? Remember, these two numbers represent different things. The constant is the y-intercept, and the coefficient of x is the slope. So when we think about the main idea here, the slope is negative. That means our graph would be going downhill. That means option A is out, option B is out. Now we need to focus on our y-intercept. The y-intercept is +4. Now even though there are no grid marks on this worksheet, you can still see that the y-intercept of this graph is positive and the y-intercept of the last graph is negative. And since the y-intercept is +4, that makes this the only option. On the back, this question talks about a zoologist tracking the weight of 3 newborn pandas. You'll notice you've been given a graph, an equation, and a table. And you're going to compare their rates of change. And since this is a story, the change is growing. So we're going to compare the rates of growth for these 3 pandas. Panda number 1, which is shown here in the graph, can be found, the rate of change can be found by calculating the rise and run, or by using this rate of change formula. So if I look at these two values, my equation or my expression would be y2 minus y1 over x2 minus x1, which is 6/2, which is 3. That panda is growing 3 pounds each week. Panda number 2 is an equation, and the rate of change is the coefficient of x. So panda number 2 is growing 5 pounds per week. And panda number 3 is shown in the chart. It looks like it's growing 4 pounds every 1 week. So that's 4 pounds per week. So panda 1 is 3 pounds a week, panda 2 is 5 pounds a week, and panda 3 is 4 pounds per week. So if you're asked which panda has the greatest rate of growth, you're going to say panda number 3. And when they ask you to explain how you know, you would describe the rate of growth for the other pandas. Panda number 2 has the greatest rate of growth because 5 is higher than 3 and 4. Last section, Pablo says that this relation is a function. In order to be a function, each input maps to only one unique output. That means no repeating x values with different y's. So let's take a look at our x values. Do any of them repeat? Yes. Do they have different y values? Yes. So that means no. This is not a function. Explain how you determined your answer. A function cannot have repeating, and now here you have a choice of words. You can say x values or you can say inputs. A function cannot have repeating x values with different y values. And this is important. You have to say that the y values can't be different. Last question. To solve this equation, you're going to combine like terms on the left and you're going to distribute on the right. Now stop and take a look. Do you notice something about your variable terms? They match. But what about your constant terms? They do not match. And when something like this happens, that's a special solution. In this case, it's no solution, or the math symbol empty set. And that concludes homework number 13.